Hi, and welcome to the fifth video on solving linear inequalities. In this video, we have a look at solving double inequalities. So there are stuff on either side of the x. We will also look at how to represent these solutions using set builder notation and on a number line. If you do not know how to represent the solutions on a number line or using set builder notation, please watch the previous videos. And if you don't know how to solve linear inequalities at all, I suggest you start at part 1. If you would like, pause this video now and have an attempt at the questions before we go through it together. So let us start with the first one. So the main aim of this is to get x by itself. So we're going to remove what's attached to the x, but instead of moving it over to one side, we move it over to both sides, and the signs of both of the elements then change. So let us do it step by step. So first of all, we would like to get rid of this plus 4. Okay, so I'm just going to put it like this. So I just wrote it out a bit spaced out so you can see what I'm doing. So to get rid of the plus 4, what I'm going to do is subtract 4. Okay, and that would get rid of the plus 4 here. But we can't just do it over there. So we subtract it on this side and on this side. So when taking it over, we don't take it over on both sides. So we don't subtract it on one side, we do it on both sides. Okay, so now what we have is 2 minus 4 is minus 2. The 4's cancel out over here, leaving us with just x, and 10 minus 4 is 6. So first, let us look at how to represent this on a number line. So I'm going to just draw a quick number line. So minus 2, minus 1, 0, 1, 2, 3, 4, 5, and 6. So for the first one, minus 2 is excluded, so we're going to put an open dot, and please revise the previous videos if you do not understand this notation. And then the 6 is also excluded, so it's a 6 inequality, so it's an open dot, and then it's everything in between, so we then join it. Okay, for set builder notation, we have x is an element of, and the first value is minus 2 and it's not included, so we use a round bracket. And the second one is 6 and it is not included, so we use a round bracket again. Please, if you do not understand the inequality, the number line or set builder notation, revise the previous videos. So let's have a look at another one. So this one here, we're not going to do that step explicitly where we're going to subtract on both sides, but we now know the rule. So we have minus 1. And the first thing is we want to get rid of this 3. So we're going to subtract the 3 on both sides, and then the x will be by itself. So 6 minus 3. So that 3, can you see we've subtracted it, we've changed the signs and subtracted it on both sides. Okay, so then what we have is minus 1 minus 3 is minus 4. We have minus x by itself. Then we have this less than 3. We would like x to be positive, so we're going to divide everything by minus 1. Minus 1, minus 1, minus 1. Minus 4 divided by minus 1 is positive 4. Remember, whenever you divide by a negative in an inequality, the direction changes. This then becomes a positive x, and this becomes a negative 3. So you need to remember that when we divide by a negative, the direction of the inequality changes. Okay. So let's represent this on a number line. So I'm not going to put in all of the numbers. I'm just going to put in minus 3 and 4. So minus 3, it is excluded. So we're going to put an open dot. 4, it is included. So these are the values of x that's greater than minus 3, but less than or equal to minus 4. For set builder notation, we have x is an element. The minus 3 is excluded. So we put an open bracket. The 4 is included, so we put a square bracket. So x as a solution is all of the values between minus 3 and 4, and this is how we represent it in an inequality. This is how we represent it in set builder notation, and this is how it's represented on a number line. Let us have a look at the next one. So first of all, we want to get rid of this minus 1. what we're going to have to do is we're going to add the 1 on both other sides. So +1 and then the 2x and then 13 +1. So we've added the 1 on both sides. So this is 8 is less than 2x, which, I mean, 2x is greater than 8, and 14, 2x is less than 14. So now we'd like to get 2 by itself, the x by itself, so we divide everything by 2. So the key thing is to do whatever you're doing to everything on the left-hand side of the inequality and right-hand side. 8 divided by 2 is 4. This here becomes x, and that becomes 7. So let us represent this on a number line: 4, 5, 6, 7. So 4, it's excluded, so we're going to put an open dot. 7 is included, it's less than or equal to. So if it's equal to, then we have a closed dot, and it's the values in between. X lies between these values. So X can take any value in between. Set builder notation, we're starting at 4, and 4 is excluded. So 4 is a round bracket, and we're ending at 7, and 7 is included. So it is a square bracket. Let us have a look at number 4. So this one here, we just have to divide everything by 3 because x is already by itself. So we get -1, x, and 4. So representing this on a number line, -1, 0, 1, 2, 3, 4. And maybe you can think about the solution as we're doing it. Well, -1, what kind of dot will we have to have for -1 if it's a strict inequality? I hope that you guessed that it was an open dot. And for 4, it's also strict inequality, so both of them have open dots because they're both less than or greater than with no equal to. For set builder notation, again, because they're both excluded, we're going to have -1 to 4, and they both have curly brackets. Sorry, round brackets because they're excluded. Okay. For the last one, let us get rid of that 1 by subtracting it on both sides because it's added. So this is -3 - 1 is less than or equal to x. 4 - 1. So we have -4 is less than or equal to x, and x is less than or equal to 3. So again, on the number line, I'm not going to put all of the numbers in the middle, but we have -3 and 4. Again, let's see if you can guess for the, sorry, it's supposed to be the other way around, -4 and 3, -4, 3. So for the -4, what dot will we have to put? Well, we look at the inequality, it's including, so it's a round dot. And for the 3, again, it's also including, so it's a round dot again. And it's everything in between. For set builder notation, -4 is included, so we have a square bracket, and 3 is included, so we have a square bracket. So what I hope you understand is that an inequality, our greater than or equal to, correspond to a closed dot on a number line and square brackets in interval notation, whereas the strict inequalities correspond to an open dot and round brackets. So when taking it from inequality to number line or set builder notation, you're going to have to understand how do the endpoints correspond, the notation. Please have a look at the previous videos if it's still murky. If you have understood it, that's great.